Hello friends, welcome to the session. Continuation of concept of LC circuit or tank circuit. Still now the concept of LC circuit that I discussed in two cases. Now we'll see the case 3. Under case 3. Yes. Let us consider LC circuit. It may be thyristor or diode. This I, the supply voltage is Vs. Okay. It may be thyristor or it may be diode also. Okay. Then how to simplify the circuit I already discussed. Let the initial voltage across the capacitor is Vc of 0 equal to, this is V0, that is plus V0. The initial current in the inductor is IL of 0 equal to I0. In the previous case, I consider only initial voltage across the capacitor. I am not considering initial voltage, initial current in the inductor. Both are considered. Then what is the expression for I? Then directly I am writing same, apply KVL, substitute initial conditions, apply Laplace transform, substitute initial conditions, then apply inverse Laplace. By simplifying this, then what we can get? I equal to Vs minus V0 into square root of C by L into sin omega naught t plus I0 into cos omega naught t. This expression for I. If current in the inductor is also given, then how to write the voltage across the capacitor? Vc equal to Vs minus V0 into cos omega naught t, Vs minus V0 into cos omega naught t plus I0 into square root of L by C into sin omega. This expression for voltage across the capacitor by considering how to simplify that I already given. Apply Laplace, but here the only difference is I given the derivation without any initial conditions, where I taken Vc of 0 equal 0, I of 0 equal 0, but you substitute that conditions there, then you can get these expressions by applying inverse Laplace transform. Then this is the expression for current if LC circuit is given both with initial conditions. Okay. This is under case 3. But here I want to write one expression here. See, let if Vc of 0 equal to 0, the initial voltage across the capacitor is 0. This is a special case in this case 3. Then what is I you written? I you write, tell me, I equal to Vs into square root of C by L sin omega naught t plus I0 into cos omega naught t. Yes. Let this is A and this is B. Shall you write In this total current, what is the expression for peak current? The expression for peak current equal to, square root of, how to write, Vs into square root of C by L, A square plus B square plus I naught square. Shall you write what is the expression for theta? You calculate angle tan inverse B by A, I naught by Vs into square root of C by L. This angle for theta. Okay. Once you know the peak value and you know the angle, then expression for current I equal to Ip into sine omega t plus theta. Like this you calculate. This is expression for I. Then what is the on time? T on equal to, what is the on time? T on equal to, you write pi minus theta by omega. Pi minus theta by omega. How much time the thyristor will on? Pi minus theta by omega. If there is no any initial current, if I naught of 0 also 0, that means if Vc of 0 equal to 0, I naught of 0 is also 0, then what is the on time? Pi by omega, that is pi root LC. That means without any initial condition in LC circuit, the device conduction time is pi root LC. The device conduction time is pi root LC without any initial conditions. How much time the device will on? Pi root LC time it will on. If initial conditions are also given, if there is no initial voltage across the capacitor, with the assumption of initial current in the inductor is given, then this formula you can apply. Clear? Okay. Now, similarly, if Vc of 0 equal to 0, then what is Vc? If Vc of 0 equal to 0, the initial voltage across the capacitor is 0, then what is the voltage across the capacitor, you tell me? Vs, the voltage across the capacitor is Vs minus Vs cos omega naught t, Vs minus Vs cos omega naught t plus I naught into square root of L by C into sin omega naught t. Then I want peak voltage across the capacitor in this case. What is the peak voltage across the capacitor? The peak voltage across the capacitor is Vs plus square root of, that this is A and this is P. Then how you can write? Vs square plus I naught into square root of L by C whole square, you write. This is peak value. This is according to some equations I am writing, but that you know. But directly you take that I am writing Vs plus A square plus B square. This indicates the peak value. Vs plus square root of V square plus I naught into square root of L by C whole square. Okay. This about case 3. Clear? Concentrate. Quick. Here this given I am giving these expressions with the assumption of there is initial voltage across the capacitor, there is initial current in the inductor. Quick, note down. It's over. See the case 4. Let's concentrate. Yes. Let us consider RLC circuit. Instead of LC circuit, you take the RLC circuit. This R, L, C. This is I. This thyristor or diode. Then apply the KVL for this loop. Then what you can get? I into R plus L into di by dt plus 1 by C into integral I dt is equal to Vs. Then with the assumption of let Vc of 0 equal to V0, IL of 0 equal to 0. With this assumption I am explaining this one. Then in this case, apply Laplace transform and apply inverse Laplace transform. Consider the initial conditions and simplify that. Directly I am writing. Then you can get current I equal to Vs minus V0 by omega L. Vs by V0 by omega L into e power minus zeta t into sin omega t. This expression for I. Okay. I equal to Vs minus V0 by e power minus zeta t into sin omega. The expression for voltage across the capacitor is Vs minus V0 into omega L. This Vs minus V0 into omega L. This you write R by 2 into sin omega t plus omega L into cos omega t. This is the voltage across the capacitor. Quick note down. This is into e power minus zeta t. Okay. Yes. Then what is omega L? Omega is square root of 1 by LC minus square root of R square by 4L square. What is zeta here? Zeta equal to R by 2. Damping coefficient or damping ratio. Zeta equal to R by 2L. Okay. This Vs minus V0 by omega L into e power minus zeta t into sin omega t. This Vc equal to Vs minus V0 by omega L into R by 2 into sin omega L cos omega t e power minus zeta t. Where omega equal to 1 by LC minus square root of 1 by LC square root 1 by LC minus R square by 4L square. That is zeta. That means omega is nothing but a square root of omega naught square minus zeta square. Like this I am writing. Omega naught is 1 by root LC. 1 by root LC square means 1 by LC minus zeta is R by 2L, that is R square by 4L square. Okay, this is with the assumption of case 4, that is RLC circuit. How to write the formula, that you concentrate. This I given. Clear? Okay. Okay. This about concept of LC circuit or tank circuit. But in this, mainly concentrate 3 models of questions. For example, this I am giving. For example, how to approach the problems that I am explaining. If any circuit is given like this is thyristor or diode. This is given as LC circuit. LC circuit. Okay, if it is given as a LC circuit. Here there is no any initial voltage across the inductor, there is no initial current through the inductor. So there is no initial current through the inductor, there is no initial voltage across the capacitor, if it is given. In this case, how to write the formula? I equal to Vs into square root of C by L into sin omega t. Okay, what is omega naught? Omega naught equal to 1 by root LC. How to write the formula for current directly? Then, because there is no initial voltage across the capacitor, initial current in the inductor. What is I? This, like this we can write. What is IP equal to? The peak current equal to, directly this Vs into square root of C by L indicates peak current or peak commutating current. Okay, this I am writing as a note. How to approach the formulas directly without remembering this concept also. IP equal to Vs into square root of C by L. Now can you tell what is the peak voltage across the capacitor? Peak voltage across the capacitor equal to Vs. The point to remember, without any initial conditions across the capacitor charged to a maximum voltage of 2 Vs. Once you know the peak voltage across the capacitor, what is the voltage across the diode or voltage across the thyristor? This voltage minus this voltage at steady state condition. Vs minus 2 Vs, that is minus Vs. Then what is the on time of diode? That is pi root LC. How much time it is on? That is pi root LC. But in this case, the point to remember, the circuit turn off time. The circuit turn off time equal to pi by omega. In this RLC circuit, the circuit turn off time equal to pi by omega, where omega is not 1 by root LC. Omega equal to 1 by root LC minus R square by 4L square, pi by omega. That means in this circuit, the current is 0 to omega t equal to pi. Then the circuit turn off time equal to pi by omega. Understood? What is the circuit turn off time? You know. Okay. The time taken, a reverse voltage applied across the device in 1 cycle of operation. T on equal pi root. If it is given like this, this is 1. If example 2, how to, here I am not solving the problems, directly I am writing how to write the formulas. If it is any circuit is given like this. This LC circuit, this is Vs, this is diode. Let the initial current in the inductor is 0. The initial voltage across the capacitor is plus V0. How to say that, how to identify it is a plus V0 or minus V0? I told already. Now diode conducts in this direction. Diode conduct in this direction. And according to current direction, this plus minus polarity. Capacitor polarity is also given like this, plus minus. This polarity and this polarity is same. That's why Vc of 0 is plus V0. If Vc of 0 is plus V0 is given, then how to write I equal to Vs minus, here plus is given, you take minus. Vs minus V0 into square root of C by L into sin omega. How to get this one? That already given. Sin omega naught t. Then what is the peak current you tell me in this case? Peak current equal to Vs minus V0 into square root of C by L. Can you tell what is the peak voltage across the capacitor? Peak voltage across the capacitor is, without initial voltage, the capacitor charged to a maximum voltage of 2 Vs. But here plus V0 initial voltage is given, you take minus V0. Then what is the voltage across the diode? Voltage across the diode is Vs minus 2 Vs minus V0. Supply voltage minus voltage across the capacitor. Supply voltage minus voltage across the capacitor. Okay, this is for any initial current. Understood? Okay, any initial current, that is the formula you can get. But here, if there is no initial current in the inductor, the on time of diode is pi root LC only. If there is no any initial current in the inductor, the on time of the diode equal pi root LC. That I given formula, tan inverse I naught by Vs into square root of C by L. If I naught is 0, then what about the theta 0, then theta is 0, what is T on pi by omega? Pi by omega is nothing but a pi root LC. That formula I already given. If there is no initial current in the inductor, always the on time of diode is pi root LC. It may be thyristor or it may be diode, pi root LC. Okay. Example 3. If it is asked like this. Okay. If it is asked like this, then this is the current in the, this is the diode or thyristor, and this is LC circuit. It may be diode or thyristor. Let this voltage is Vs, this is L, this is C. Still in the circuit, IL of 0 equal to 0. Then Vc of 0 equal to, let this is minus plus V0. Now according to diode will conduct this direction. According to current direction, this plus minus, but this is minus plus. That's why Vc of 0 equal to minus V0. Like that you take. If Vc of 0 equal to minus V0 means, then how to write the formula, you tell me? How to write the formula? Then what is I equal to? Here minus is given. Minus is given. If it is not mentioned, based on the direction only you can take. Current direction and polarity only. Then how to write I equal to Vs plus V0 into square root of C by L into sin omega naught t. Here negative is given, here positive you take. Here positive is given, you subtract. Like that you remember to solve the problems. Then how to find peak value of current? Peak value of current equal to Vs plus V0 into square root of C by L. Once you know the peak value of current, then what is the peak voltage across the capacitor? Without initial voltage across the capacitor, capacitor charged to a maximum voltage of 2 Vs. Capacitor charged to a maximum voltage of 2 Vs. Then plus capacitor charged to a maximum voltage of 2. But here minus is given, you take plus. Then this is the peak voltage. Then what is the voltage across the diode? Vs minus 2 Vs plus V0. Then what you can get? Minus Vs minus V0. Then what is the on time? On time of diode is, because there is no initial current in the inductor, then directly you take pi root LC. Clear? No doubt. Quick. Based on the given initial conditions, how to apply the formula, that you concentrate. It may be diode or thyristor. Even thyristor also you take, then you apply the same formulas. Okay? Quick. No doubt. Okay. One more observation. If the circuit is given like this, concentrate. All these are derived by applying the Fourier analysis. How to apply the Fourier analysis? At the starting I given. Okay. If it is a source free LC circuit is given like this, it is a source free LC circuit. This plus minus V0. This is switch. Okay. But for the conduction of diode, it must be minus plus. For the conduction of diode, it must be minus plus. Then only diode will conduct. Understood? Now in this case, how to apply the formula, you tell me. Now according to diode conduction, this is the direction of current. As for diode conduction direction, this is plus minus. But it is minus plus now. That's why initial voltage across the capacitor is minus V0. If initial voltage across the capacitor is minus V0, how to write I equal to? As for this formula, it is minus V0, but Vs is 0 na, supply source free circuit. Here source is not there, Vs is 0. Then how to apply? V0 into square root of C by L into sin omega naught t. That is V0 into square root of C by L into sin omega naught t. Correct? Shall we write what is the peak current? The peak current equal to V naught into square root of C by L. V naught into square root of C by L. Clear? Shall we write like this? What is the peak voltage across the capacitor? Peak voltage across the capacitor is, the peak voltage across the capacitor is Vs is 0. Peak voltage, maximum voltage V naught only. The peak voltage across the capacitor is V naught. You substitute Vs is 0 here, then you can get V naught only. Next, what the voltage across the diode? The voltage across the diode equal to how much? You substitute Vs is 0, then we can get the voltage across the diode is Vs minus V naught. This voltage across the diode is nothing but it is minus V naught only. Yes. Can you tell what is the diode conduction time? The diode conduction time on time equal to pi root LC only. In this circuit also pi root LC. In source free LC circuit also the nature of the current is what nature? Sinusoidal oscillations. Where this current is maximum at omega naught equal to pi by 2. Like that you write. Okay. Then how to write the formulas in source free circuit? Clear? Okay. That you concentrate. If diode direction is given like this, then if it is given as plus minus, as for current direction is plus opposite, then again you take the negative voltage. If it is a negative voltage like that. Understood? Then how to approach the problems? By seeing the circuit. That you concentrate. What is omega naught here? Omega naught equal to 1 by root LC. Okay, this is about concept of LC circuit in different cases that I discussed. If initial current in the inductor is also given, how to write the formulas that I already given? Follow that, then you can answer any question. Okay. With this, the concept of LC circuit or tank circuit is completed. Now, this is the minimum knowledge. This is the basic concept is required. This minimum knowledge is required to understand the concept of commutation circuits or the types of choppers based on commutation. Okay. Now I want to discuss types of choppers based on commutation. That is the third concept with respect to choppers. But I told already in the discussion of commutation methods at the starting, in the power semiconductor device, in the second chapter, the last concept I given, that is types of choppers, what are the different types of commutation methods. In the discussion of commutation methods, I discussed only in detail about natural commutation. But forced commutation and load commutation still now I am not discussed. I told one point, the remaining forced in detail about, but I given only introduction of the forced commutations, where? In the power semiconductor devices. But I told one point, in detail discussion of forced commutation methods and load commutation methods I will discuss in the discussion of the choppers. That means in the DC to DC converters discussion I will discuss. That means the next concept I want to start, what are the types of choppers based on commutation. In the types of choppers based on the commutation means I will discuss the commutation method. Parallelly I will discuss the what is the types of choppers also. For example, first I will start with what the load commutation, that is class A commutation, that will complete. Then I will start class B commutation. When I start class B commutation means indirectly I am discussing the current commutated chopper. Class B commutation is also called which commutation? Current commutation. That means I am discussing the current commutated chopper means indirectly we are studying the current commutation. That's why no need to remember separately for current commutation, current commutated chopper separate formulas. Then I will start the voltage commutated chopper. Then voltage commutated chopper means I am discussing the voltage commutation or class D commutation. That means no need to remember the separate formulas for class D commutation and voltage commutated chopper. So in formulas, because why it is called voltage commutated chopper? Because we are using voltage commutation, that's the reason why it is called voltage commutated chopper. Then I will discuss separately what is the load commutated chopper, what is the zone chopper. Just I will give 1 or 2 points. In detail discussion not required. In detail discussion of load commutated chopper and current commutated chopper is important, not load commutated. voltage commutated chopper and current commutated chopper is important. But I will give 1 or 2 points with respect to load commutated chopper and Jones chopper and Morgan chopper. Then separately I will discuss what is the class C commutation, that is a complementary commutation. I given some introduction only. Complementary commutation is used in parallel inverter. Class B commutation is used in current commutated chopper, and class D commutation is used in voltage commutated chopper. Class B commutation is used in current commutated chopper. Like that, load commutation is used in series inverter. All this some introduction I already given, but in detail discussion of forced commutation methods and choppers that I want to discuss. Okay. Then class C commutation and class C commutation. After discussing this, then I want to discuss. With that, maximum choppers concepts will be completed. Then one small concepts are there, that is what exactly voltage control techniques in choppers, and I want to give what is the circuits for SMPS, switched mode power supply circuits I want to explain. Okay. So when I start this will not complete. That's why in the next session we will continue with what is the types of choppers based on commutation. Means indirectly I am discussing the commutation methods also. Clear? Concentrate how to approach these problems by seeing the circuit, how to write the formulas also, that you concentrate. Okay. Okay. For example, if the circuit is given like this, one simple example I am giving. This is LC circuit. Let this is 100 volts. And this is 2 millihenry, and it is 2 microfarad. The initial voltage across the capacitor is 20 volts. Like this it is given. Then can you write what is I equal to? Yes. This is the direction of current. Diode will conduct unidirectional. And as for plus minus, this also plus minus. This is plus minus, this is plus minus, means initial voltage across the capacitor is plus 20 volts. By seeing the circuit only you identify. If it is plus 20 volts, means how to write the formula? Here positive is given 100 minus 20 square root of C by L. C by L means 2 by 2. This is also 2 millihenry. Okay, 2 millifarad. Then sine of 1 by root LC, root 2 into 2, 10 power minus 6 into T. Then how to write? This is 80 into sine of 1 by 2 into 10 to the power of minus 6 into T. This expression for current. Like that. That means they don't mention sometimes if it's a positive voltage or negative voltage, then you ready to identify if plus minus is there. Then what is the, can you calculate what is the peak current? Peak current equal to 80 amperes. No need to calculate, this directly indicates peak current. Can you tell me what is the voltage across the peak voltage across the capacitor? If it is given like the what is the peak voltage across the capacitor, you tell me quick, come on. Then without any initial voltage 2 into 100, 200, but it is given as positive voltage now, that's why you take minus. Then how much we can get? 180 volts. Can you tell what is the voltage across the diode? This is 100 minus 180. 100 minus 180 means how much we can get? Minus 80 volts. Like this you can do. Understood? How to write the formulas directly, that you concentrate. For example, if the circuit is given like this, this is diode, this is inductor, and this is capacitor, this 100 volts, this minus plus 20. Then this is the current direction. As for current direction, this plus minus, this is minus plus. That's why VC of 0 is minus 20 volts. Like that you identify. Then it is minus 20 volts means I equal to, minus is given, then you take plus, 100 plus 20 square root of 2 by 2 into sine of 1 by 2 into 10 power, this is minus 3 now. Out, you bringing out of root, out of 10 power minus 3 it comes. 10 power minus 3 into D. Like this we can solve. Can you tell what is the peak current? You tell me. Peak current equal to 120 amperes. This directly indicates peak current. Can you give what is the peak voltage across the capacitor? 2 into Vs, 2 into 100. But it is given as minus, then you take plus. How much? 220 volts we get. Can you give what is the voltage across the diode? How to solve? Voltage across the diode equal to 100 minus 220. 100 minus 2. Directly. No need to remember all these formulas. then how much you can get? Minus 120 volts. Like that you can solve. Okay. Like this, any model is given, based on that how to approach the problem. That's why directly I am giving the formulas like this. Okay. Yeah, thank you. In the next session, we will continue with what are the types of choppers based on commutation. Indirectly, we are studying the commutation methods also. That is forced commutation method in detail, and the load commutation method is also in detail. Okay. Thank you.